feedback to that from a cosmological point of view. But the more I work on this topic, on constants of nature, the more am I sure that I have the absolute proper value of G. And that has a lot of geometric reasons. And from pure numerical point, I could not judge. So I could not say my value of G is better than Gerd's, or Gerd's would have put measured constants in and got some whatever other theoretical value of, and they would all be equal, unknown whether they have the allowance mathematically and physically to go to the digit precision they reflect. Most people don't work with Mathematica or a similar computer algebra system, which there are not so many which are good, who tracks precision automatically. Now, many might not know, so I will repeat that here, that when you multiply two floating point numbers and one floating point number has 5 digits precision, in the sense that you measured something and you have not more precise measurements because your ruler has only 5 comma after the centimeter, and so you have millimeters or something, or whatever is your measurement scale, you cannot measure infinitely precise, depending on the length, or even not at all. When you measure the fractal length of the coastline of Great Britain, it is depending on your ruler size what you get. So the attempt at measuring a length on a fractal border is nonsense, and you have to recognize that. That is per definition that subatomic particles are not agreed on a lowest, smallest length. Would we agree on some ice-based smallest lengths, then we could even fractal measure these borders, because we say we would not go post subatomic things, and the rest is just a little bit fractal math on how many atoms you need to have the coastline of Great Britain. I can even ask Mathematica. I bet my math on this, that there is an answer in Wolfram Alpha if you ask properly. And the real thing is, when we have high-end measurement values on Planck constant, on electron charge, and even combined values of that. So sometimes experiment can do combined values like, say, electron mass over Planck constant, and the combined value is measured, and that has to be cancelled out. Or sometimes it's a value of something over alpha. Then alpha can be factored out if you have a very precise electron mass measurement, but you get not a direct one. It really depends on your experimental skills, and when the theoretical skills come together, most of the time it's quantum mechanics which is on board. And while I have learned in the past 20 years, and more so the last 3 we were here in ResearchGate and Tegs together, that quantum mechanics is probably on the right path, while theory of relativity and whole of gravitation theory, in the sense of whole of cosmology, is on the wrong path. And Gerd knows better than me why. Even if I read his paper 20 times, he will know better than me why. But the constants of nature, interestingly, can from ice-space theory be deduced by logic. So when you have one constant equation and there's a physical relation, and there are lots of, where the constants are, if you want that or not, they do interrelations which are physical. And the ice-space theory, by multiplication of prime numbers and geometry like P and golden ratios, shows that. So you get in the end some numbers which you don't understand, and that number may or may not factor out to some prime numbers. And like in the case of 1/6961, where I 20 years didn't know what that number means, I know today that it is the quantum of time. And the paper unequivocally shows that is quantum of time. Even if you don't like that, you have to accept that there is no bending time, and hence all theories, including theory of relativity, which tell me the time bends, is just nonsense, and that's it. You have to see what everybody sees and not think what everybody thinks. And I'm thinking Albert is wrong completely, because there is no 4D space-time in the way we see that. That does not make theories like yours, Gerd, incompatible to them, because you don't need a continuum to have the proper theory in it. What you need is cells which are able to have relative motion to each other, which are not bricked into a Lego hard-covered space, which is, for example, 3-dimensional geometric and infinitely open to all sides. How you get that is a different matter of a model which has to be seen, and is outside of my scope of ice-space. Ice-space just tells what the relations are and how precise they are and why they are. What model you make of with that, I actually don't imply. Yeah, I can suggest something as it probably is 10-dimensional with 6-dimensional subspace, probably is not. But with these exponents I see in the I space, I can give only suggestions. And the theory of the gravitational constant in I space was given on a paper in IMS 2015 in Prague, the International Mathematica Symposium there, which had a great resonance to a lot of people because 10 years ago that was really more new than it is today. Today everybody discusses about what is the value of G, and I have this and this equation. And since the CODATA committee has in 2018 normalized Planck constant, electron mass, and several others which belong to that, you cannot do there's just one, to exact values like the 299792458 meters per second of the speed of light, which they did long ago. Some people think, wow, now we have much higher precision on these constants. They are exact. So let's calculate backward with these exact constants and suddenly get much better values for our other values. And I'm really happy to tell them they are all wrong, completely wrong. And why is that? Would that be the case, that something has been overlooked by the CODATA committee? Well, they're even the best people on the planet, the best physicists. Lots of people from Wolfram Research are actively working with them, as far as I know. So trust me when I tell you these people don't overlook anything, at least not anything really obvious. And anything really obvious would count to overlook a constant, which you can now calculate in more precision after locking these values to exact 8 or 9 integer digits. They for sure have precisely calculated all these constants you can lock. And I personally know the person who has supported that technology. And the Wolfram, I have a Mathematica notebook I can freely give to everyone from this person who shows what constants are in exactly what relations and why. That is a masterpiece of art. Is about 20 pages of Mathematica. I could never write that myself. This is really genius work. And it shows what constants of nature relate exponent-wise, physically, to each other constant by sheer algebra. And said this is really extremely clever. And if you nail one, you shift the other one. So all the dependencies of the CODATA normalization calculation are implicitly in there. That said, that means when you want to find something new, you have really to find a relation which says, wow, that cannot be accidental. And my original G calculation was actually not that good. It was 4 digits where I have seen 9s and said, well, that could be an integer because of the 3s, and 3 times 3s gives 9. Just is it maybe the value 3 instead of 2.999? Yeah? And it worked out because later, much later, with this assumption that 2.999 was a 3, I could see immense other relations which cannot be accidental by geometry, like that of alpha G, the allowance of the quantum of gravitational force, the quantum of gravitational force being alpha G squared times the Planck force, which I did not have as an equation in derivation. It's actually not even published. I have published it in the form of a preprint, of course, but it's not peer-reviewed. And all these kind of things gave me still the idea, what are the other people are doing on the world? And I always get ResearchGate suggestions, and quite a lot, actually, one per week, where somebody claims I have a new value of G or a new value of Planck constant, and is this and this geometry and this value for that and that reason, and is even exact. Sometimes it's just a multiplication with more precision. That is not really helpful, actually. But when it's really geometry with pi, with golden ratios often, and some integer values, why should it be less correct than my I-space approach? It could be correct. So I hope I have the time in the next weekend. So I take that, sort it out, and recalculate it with a couple of equations. And one of that calculations I want with you together do live now. This is cool because I need only 15 minutes to do that on one of the weekends before I went to vacation. And it's super easy to understand for everybody. And the equation is so simple that it actually shocked me. And it is much easier than my own equation. Nevertheless, it's wrong. We would need more than 15 minutes to see in detail why that cannot be the correct version, because the relations to alpha G and others are just making no sense. And When you go to the alpha G, you have exponents like power of 8 into your equation. So all your errors, how small ever they are in the beginning, they go by an exponent of 8 up, and you lose your window of confirmation with other constants, which are measured with a narrow window. And when you are outside of, say, at least 2 sigmas, you get critical. And when you're outside of 5 sigma of your error window, you just forget your idea. It's just wrong. Yeah? This is, you are not able to fix this by plus, I need a correction factor thing. So all these ideas which I normally get are plus signed, in the sense they have an idea for a value, like say golden ratio squared, that give the wrong value. So they add something up, say golden ratio to the power of 5, they give another value and add something up, and suddenly you are close. So it is really cool when you are able with 2 plus signs and golden ratio in an exponent to get close to the value of alpha. And it could even be that there is some physics behind, which I don't justify for these kind of calculations. But what I'm absolutely sure is iSpace has no such things. iSpace only adds 1 or -1 on some equation, as would be normal in the when you take a bracket off and you put something out, you get a +1 for the things, and that is a natural one from algebraic point of view. But not say we have to add 5,750 divided by 15 to make it correct. Yeah? And if you have such numbers, no objections, but then please unequivocally tell the reader what is the physical significance of that plus sign. What is the first part of the plus? What is the second part of the plus? Why do you need it? And if you have a good physical reason, then why not keep it? Yeah, I'm not objecting, but just having a plus sign to get the correct value is just numerology, hard as it is. And if you have the will to follow me live, I would say I go into presentation mode. I will click on presentation. Someone have to give me, I think, allow me that if I remember properly. I want to share my screen.
Yeah, let me.
Now, I choose my primary screen, full screen, and websites. Yeah, and mute.
Share screen. Yeah.
Okay, I'm live. Good. Can everybody see my screen now?
Not really.
Okay.
I can see. Let me add to stage and see whether that.
No. Yes.
Now we have. Okay, so let's close that live window. Let's close the mail,
Okay.
of course. Let's close all that what doesn't belong here and open the Mathematica. I move that to the end. The document I wanted to show you is this thing. It's called iSpace Newtonian G from C, electron charge, and the 7th root of 10. And trust me, it will not become easier. But this is not how it started. I didn't make a title in here, no date, nothing. It's wrong what I'm telling you here. Yeah. So in every second sentence, I will repeat, that is not the correct solution. I want to show you how easy it is to get a seemingly correct solution fully within error range within minutes. And I didn't even use Mathematica. I used my brain to deduce that. It is a 4-digit solution. And on G, I searched for over 10 years. And here I had it in 15 minutes. I could have found this solution first. I'm very happy that I didn't, actually. So let me explain what happened. I received a paper where this value, 8 times arcus cosinus of -1/3 divided by 11, was a numerical value, geometry, okay, in some form, could be, was multiplied with the speed of light c and the electron charge a to give the value of g with wrong units and so, but he was claiming that is the correct value because of this and that idea. So I was starting to look at the individual values because this is standard iSpace. So I said, okay, what actually is numerically arcus cosinus -1/3? It's 1.91 and it's exact. Okay, why not? What is arcus cosinus of 1/3? This is 1.23, just to make a cross check. So it's close. It's like, okay, I have no feeling for that numbers. What would be arcus cosinus of -1/p? 1.8. So you see 1.8 and 1.9 is close, but gives a total different multiplication. So when you multiply things, not add up things, is really hard to get the right value by multiplication. Really, really hard. So let's give him a chance and multiply what is 8 times arcus cosinus -1/3. So it's 15.28. So, okay, still a nice value. And what is 8 times arcus cosinus -1/3 over 11? So it's 1.38955. I was like, okay, this is nothing special what I can see. I-space theory tells when you want to integerize things or see if they are really quantum, you take also the inverse to make sometimes, if you are lucky, see that after a flow of digits, you get only zeros. For example, that could be only zeros, then it's quantized. Or sometimes when you're super lucky, you get the quantization from here to here. Then you have for sure something quantized because that is never accidental. Then you found some round of error of some constants in between. This is really, really rare, but happened 1 or 2 times when I evaluated I-space theory. So this is the critical 2 things which we have. So what do I do next? I'm routine checking because I have a Mac here. Yeah, this is a MacBook. It's 10 years old, nothing special. macOS Mojave 10.14.6, but most people don't know that Macs have Spotlight search. That is that nice thing here. So I can say where in what documents I type the name Wolf. It was like Wolf, here you go, Wolf something, anything, or what is whatever you want, you can type it in there. And Mathematica has a plugin for that Spotlight search. And that is real time at the Mac. This is a daemon. This is much, much faster and much, much sophisticated than a typical Google search, which would index your hard disk overnight. So once you save a document, milliseconds later, you can index that with Spotlight search in real time. And what this plugin magically do, would I search for a number like this, 1.385554, which is a calculation which should only appear in this paper, and I do that in Spotlight search, where you see what happens, takes some time, and here it is, Newtonian G from C, or if I show me that on the desktop, a second later we are in this document, and I found the value because it is calculated in here and saved. And this is magic. Now, when I search for the inverse, something really crazy happens. I show you that live. I don't assume that I have similar values to the full digits, yeah? But I could have similar values to, say, 9, 10, 11, or less digits. So what I do is I start with the full value and see what happens. And that is, of course, in this document, but it was also in this document, I-space analyzing Gudlaugur Kristin Ottoson of our natural space. And that has nothing to do with this person who wrote the idea of this G, okay? Gudlaugur Kristin Ottoson is a very, very clever physicist and mathematician in Iceland, whom I also track his ideas with, and he came very early up with the golden ratio as an idea for a lot of things. And when you look into this paper then, when I open that, then you find that I already did calculate that value with respect to his ideas and found that the 1 over the 7th root of 10 gives a near identical value up to, we have to check there, 71965, 71968. So within the rounding error, this is a 5-digit precision after the comma, which means this is a fully valid 4 to 5-digit G value, if it is a G value. Because 8 arcus cosinus minus 1/3 over 11 might give a proper value. Now let's see if it does, okay? So what happens when we multiply this value numerically times the electron charge? So first of all, I should show you that, of course, I have the electron charge in SI in I-space exact. You know the equation, it's golden ratio times I-space base time and so on, but that doesn't matter for the argument. I could also set the measurement value electron charge from the code data in here, yeah? And if I do that and multiply with electron charge and speed of light, then you get 6.6743 times 10 to the power of 11 and the wrong unit. But that is definitely fully in the range of the G. Was it okay? Let's change the electron charge from here with the I-space electron charge, because we know for absolute sure this is the correct electron charge. And the speed of light is not negotiated. If I put here IC is 299792458 meters per second, has no rounding errors and is an integer. EA is golden ratio and nothing else, divided by 6961, which is 1 over 6961, the speed of light, and the I-space space-time human artifact correction factor. And that's it. And when I do that now, I have an exact value. And that exact value contains this arcus cosinus, which he started with, which doesn't go away, of course, and some denominator and divisor, numerically and algebraically. And of course, I can make the electron value numeric. And here you go. And we're 6.74299943 ampere meter. And that sounds really crazy close, isn't it? So when I say, what is my G value? Well, I have 6.67411 something. They are both fully compatible. And I cannot exclude that this is full valid physics. And I cannot exclude that this is full valid physics. But I'm absolutely sure this is full valid physics. But why? Because when you look at the term, wow, it doesn't look very physical at first sight. But we have here golden ratio to the power of 6 and pi to the power of 10. And this is all where the magic geometry of I space happens. And when we do alpha G, as a cross-check, alpha G is the fine structure constant of the universe, 1.75175, and that is created from G. It's the electron mass squared over the Planck mass squared. If you don't believe, let's cross-check that. Oh, it's the electron mass squared over the Planck mass squared, and that should give true. It's true. So as you see, this is physics. This electron mass squared over Planck mass squared is surely physics. So the alpha G value is physics. And now look what the alpha G value squared contains geometry. It's a golden ratio to the power of 6 pi to the power of 10. Well, this is cool because when you multiply that with the Planck force, you get a super simple value, 3 over some, what is that? I don't tell you. Yeah, when I do that numerically, you see this 3.713 ampere second volt per meter is a force, and that is the quantum of gravitation. And the proof is, if I factorize that, well, you see, you get a factors, this 293339. So let's multiply that. Let's multiply that all to the power of 4, as you can see, 73 to the power of 4, 7 to the power of 4, and you need 2 to the power of 4. This is hidden in the 2 to the power of 16. And when you get there, it's a very familiar value, 299792458. It's, of course, just the speed of light. So what effectively shows you is the alpha G squared over the multiplied with the Planck force, and not only in I space, in any unit system, gives the quantum of gravitation. And that is rationally 3 over the speed of light in your unit system to the power of 4 times the Descartes factor. And that's it. And you could discuss why the Descartes factor in the original equation of the IMS 2015 paper of mine should be correct, but you can never discuss why that should be correct. That is correct because it's correct physics, and that's it. But when I now go back and put that value, that is G, yeah, and would calculate reverse. I don't do that. This is boring for you, but you can pretty easy see that I can do that, because when the calculation for G is implicitly in root C to the power of 4 over G is the Planck force. Yeah, C to the power of 4 over G is the Planck force. So I can easily put the C to the power of 4 out, put it to the left side, and get G out of that. It's a little bit algebra, but is doable. Then you have an independent value. And that surely is an independent value. It's super simple, gives the right numeric value, but a completely wrong geometry. Look at that geometry. What is it? On a factor integer that, you get here the speed of light, and you get 1 times 47 times 1465,478. This is the I space basetime. This, of course, comes from the E value here. And the C value is that what you see, what you multiply, and what stays is what you already see, 8, 11, and arcus cosinus, because that will never go away, and that doesn't make it more physical. Now, when you replace that thing by the idea of what I found in Spotlight, I said, hey, this is the same value, and this arcus cosinus doesn't sound physical to me. But the 7th root of 10 is maybe physical, or more physical than that, because I say we have 7 subspace dimensions, including subspace time, and we may have 10 dimensions. 7 of 10 times the electron charge, which I say is the root of all forces, times speed of light makes a lot of sense. So purely when I replace the original equation with the same thing, Then you have to calculate forward because that was the inverse and so on. I save you of all of that, what I'm doing here. And once you have the right value, 7th root of 10 times E times C over G gives nearly 1. And here you go. Then you have to correct the unit and so on and so on. I really spare you of all the other calculations. And in the end, you get a G from that. And this is the final equation. So you have 29979245858 times E times the 7th root of 10. You need to correct the unit, 1 over volt per meter times 1 over ampere second squared, meter to the second of 4. And suddenly you have the proper G here. Now, cool. There could be a correct G is a little bit low. It's not 4.1, it's 4.0. So, but I really would say within the error range, could not exclude it's wrong or right from this number. But I can already see the following. I have no reasonable way to assign volt per meter to any of these numbers here. This is possible for the 10 under the root. It's not the root, so I need to write it in front of, but why should volt per meter have 7th root of 10? Really, not really plausible. I have ampere second squared. That makes some sense. But again, I cannot really associate it to the speed of light. I cannot associate it to 7th root of power 10. And meters per second to the power of 4, here you now see it should be a speed. So you would expect 299792458 to the power of 4 or something like that, or at least a number to the power of 4. So when that would be to the power of 4, we could associate that to meters per second. It really unit-wise doesn't fit. You get the right value, and the units are just fake corrections to make it proper, in my opinion. Still, when you look deeper, you can, for example, have the Planck force calculated with that, c to the power of 4 over g, and see what geometry it gets, and so on. But the more you do with these things, the more you will see that you get away from the original diligence of that alpha g computation of I space. So this is actually the core equation of I space. Put it this way, when you put that orange, I said, that is completely correct, guys. There is nothing to discuss here. Yeah, so this is completely impossible to discuss that away. Planck force, for anyone who doesn't know, can only be measured to 5 digits as well because of the limits of G. So when I say numerically, we have that Planck force for arbitrary number of digits, 1.2102, then this is the best measured value of Planck force of Kodata. And I say it will continue here. Would you please follow I-space theory? Then you get it exactly, because that is an integer in divisor and an integer to the power of 4 in the denominator. And there's not even geometry involved. This is a naked value. And c to the power of 4 is the basic input for Planck force. So once again, when I do the calculation raw, c to the power of 4 over g, numerically, capital G, you get Planck force. You see, that is the exact Planck force. This is not an approximation. So this is beyond any doubt to be coincidental. I have the proper exponents, everything. And hence I'm, well, some would say arrogant, but I am self-esteemed enough to say, to give a reply to this person having the idea with 8 arcus cosinus minus 1/3 over 11 and say it was a cool idea, give the complete correct numerical value, but please don't waste your time. Why don't you read papers on I-space, jump on board and help us complete this thing here on the light side, not on the dark side of the thing. So numerology is just such a bad thing in physics. And I had to fight numerology for 20 years, essentially, at least the ASCII acronym of numerology. I-space was never numerology, not even in the beginning. But it is so easy to get thrown into a pot together with all other people who just want that their idea is the next great news. And I have nothing against that. Maybe the next idea is the next great news, but then physically and numerically, everything must be proper. And most people don't understand how much effort that is. That is, so I want to stop presentation. How do I do that? Here. Okay, now I'm back with video. Thank you. So I hope you enjoyed the little excursion. And what I wanted to show you is how not to do it. So the 7th root of 10 was for me a 5-minute operation to find an equal 5 digit after the comma value. I calculated even in coincidence with a physical idea of someone else. And I chose how super simple it is to get 4-digit values or 5-digit values, right? This is completely meaningless. Completely. So all theories can be completely correct or completely wrong. But when you see from the I-space point of view, you have so many other relations where you can cross-check your ideas with your own other ideas on the other side. And I think with Gerd's paper, this is the same. That's why it converges. There are so many other ideas of so many aspects converging at points and graphs and stuff, because he doesn't look only at one thing. He looks at all things together. And it comes from the electromagnetic knowledge, which is necessary to understand the universe, which I believe he is the best person in doing so for cosmology, because there is someone who has written a paper. I can show you that. I'm not sure if you can see that. This is very, very new. If you haven't read that, do that. It's from Stephen Kuhn. It's called Analytical Solution of Maxwell Equations for Arbitrarily Moving Point Charges and its Application for Ultra-Fast High-Quality Simulation of Electromagnetic Fields. And it's one of the best papers for my personal taste. I'm not a physicist, so who am I to judge? But from my personal judgment, this is one of the best papers I've ever read. And what he does there, he is stunningly able to give an analytical solution for the Maxwell equation. Now let that sink, okay?
Can you send can you email that link? Or
yeah, of course, I can email you. I don't have it here in this machine. I think I made it on the iPhone, so I will do that after the meetings. But this is easy to find. It's recently done. It is released on 6th of September 2023. It's very new. And yeah, this is stunning, because I talked to Harald as well on that. He's very, very skeptical in the beginning, but he has a read on that internally and said a couple of comments onto that. I don't want to repeat that here. It's still all ongoing, but that looks brilliant. Essentially, it makes Maxwell equation superfluous, because you have now an exact equation where you don't need to calculate the magnetic field and the electric field in extremely complicated Maxwell way. But all you calculate is the force of two particles affecting each other's. Then and only then, when they have a joint venture speed not faster than the speed of light. So when one particle is going to the right with half c and one particle is going to the left with half c, then this formula still fully applies. In other words, radio frequency is at its best. Normal engineering of radio frequency. And Stefan Kühn is an electrical engineer, actually, not a physicist in the sense of more a Mathematica programmer, actually. Where he
you mean that the Maxwell equations are superfluous? The normal solution, I think, but I cannot. No, I don't think that. What's the name? Kühn, yeah.
Stefan Kühn,
yeah. Found a different solution for an expanding universe, because I also found a solution of Maxwell equations, but another solution which what heißt das? With expansion of the universe, which means that there is an additional to the geometrical damping. There is an additional damping because of the because of the expansion of the universe.
Yeah, we will have to have a look on that, Gerd, because the equation is not easy to understand for me, and you're much better in math and physics like me for these kind of things. You're the radio expert. I'm just a programmer here. But I can assure you that this equation is multiplicative with a couple of addition subtractions for speed in there, which means it is done without differential equations, okay? So that means it can run 1,000,000 times faster on a computer.
Yeah, but what's the result? Does it explain the different measurements or
keep it slow. All it does exactly what the
supernova,
the Maxwell equations do, just without solving differential equations. Which
it's the supernova 1A experiment. Angeblich, was ist das? They think that the universe is expanding and the expansion should be increased, but it's wrong. And because of the additional attenuation.
Okay, I cannot judge that from the throwing over the fence, so I'm neither criticize nor endorse that McQueen's paper. But what I can see is a principal achievement. So Maxwell equations are incompatible to I-space because you need to solve differential equations. Differential equations cannot be solved when you only have Lego. But if I have something to multiply, and I can, with multiplication, get constants of natures, and then suddenly someone finds you don't need to solve differential equations to have the exact same equations for light, magnetic, and electric fields by solving the forces first. And when you have the forces of the two particles, you make it Newtonian. So actio-reactio. So he solves the exact same problem by purely looking at the forces of the two particles. And if you have the path curves of the combined accelerated, so he can calculate acceleration, not just static Maxwell equations, any accelerated form of Maxwell equation. But any magnetic field in any order, if with the speed of light or 0.9 of the speed of light, or it just works.
But it's a different solution for the old solution of the Maxwell equations.
His goal is to get the exact same output of the Maxwell equation you would get when you do the calculation slowly in the traditional form, not more or not less the part that I am understanding.
Send me the link.
Please have a look on that.
But I think I have already have a look to this file, but I will reread it.
I found it for a programming perspective intrinsic, and from an I-space perspective very, very intrinsic, because it means this is the first time I see that there is a bridge to quantum mechanics, because quantum mechanics is all over Maxwell equations, and I cannot really combine it with I-space. Even when I would study physics, I would not be able to combine it, because differential equations are what they are. They are partial differential equations most of the time, and they cannot be solved easily, if at all. And when you do some solution for an equation, and that equation holds, I'm not saying 100%, but in all practical cases, then you likely have found a model which is compatible to multiplication, and that is compatible to I-space. So in other words, I can put the I-space constants into his solution equation and see how they would propagate, giving accelerated mechanisms, which you would predict then strict masses in an accelerator, which is impossible with other methods so far.
But you can solve differential equations by multiplication. You must only found,
but not the Maxwell ones, unfortunately.
No. The Laplace transform, and to solve, you must only multiply and divide the Laplace transform, and make after a solution to retransform to the from the from the, warte mal, Bildbereich, was ist das Bild? Was heißt Bildbereich auf Englisch?
Image area?
No.
I'm not sure what you're after, Gerd, but I'm a Mathematica user, so I'm a moron.
The Laplace transform is...
ask Mathematica to solve it for me.
No, the Laplace transform...
in the library.
The Laplace transform as well built in Mathematica. You look for inverse Laplace transform.
But this is a mathematical problem, how to solve differential equation, and it is not clear at all if differential equation is physics or just a model. In a fully integer world, the approximation of curves is subsumming, and subsumming is building sums, integer sums of pixels, and the curve above these sums is the approximation, which then would make the whole linear algebra as we know it to be the approximation of I space, which would be the more physical part of it. But it could also be reversed.
Have a look at Mathematica, Laplace transform. I used it also in my article or book to solve differential equations. And Bildbereich is a complex variable domain and frequency domain. You change from one domain into another, and have a look. It is built in Mathematica.
Yeah, obviously. But as I said, I'm a fan of real values, especially multipliable real values, and I'm not so fond of complex numbers at all, because anything you can measure is just in your brain, in my opinion.
No, the complex, there is no complex number unless you use the frequency domain. There is because have a look.
You can always transform. I know that you can transform, but the question what I have is, should you? You should stay at masses, energies, and trajectories of that masses, and that will give fields. And what we do is constantly is we calculate fields, and these fields should tell our masses to move. And this is what I really don't like, because it's hard to calculate, and I'm not a mathematician.
And it's not a very good translation for the Bildbereich. Moment. Because
let's do that together when we are the next time sitting and having a look on these things, because we need to calibrate our last. We haven't completed our last sessions on merging the I-space values with your paper. I have not time yet, unfortunately. I'm really sorry about that, because that would be giving insight for me to understand better what you are actually doing there in your calculations. I only have your numerical result evaluation so far, and we have seen that
it's not correctly translated. Both translators don't Bildbereich.
Don't worry. We find the German right translation to that, what you want to say.
Yeah, I will have a look in my.
So that's it about from my side. Are there any questions of you then? Firstly, have I made the point clear why I wanted to say that you can have good ideas on simple multiplicative, even like E times C times the 7th root of 10 is really nothing in the sense of an I-space equation. Nevertheless, I took a long 3-4 days full time to prove myself this is not a better solution than the one I have, and is easily wrong. And so
das gibt's doch nicht. Yes, I have. This is the figure domain. Is der Bildbereich the figure domain, and there is yes, and you can go from the figure domain to the frequency domain. So now until figure domain.
I'm a bit lost
from Laplace
value, I think.
In Laplace transform, yeah.
You have Fourier. Fourier is frequency and time.
Right.
Laplace is a flow, so it should be a flow, like a flow. Laplace represents a flow, right?
No, Laplace transformation or Laplace transform.
So it is
It's just a mathematic.
You get the Fourier spectrum with the inverse Laplace transform, and this is what you can easily calculate in one direction, but not easily in the other. It's very hard in the other, and that you can see that easily in your when you have a sound receiver at home. You see the frequency spectrum analyzer dancing. That was very prominent 20 years ago when the people started programming these things with 8-bit computers in the receivers, and they were very proud that they did the fast Fourier transform to show you the equalizer values in real time without doing complex mathematics.
Some years before, the transformation and retransformation took place using correspondence tables. But now it's possible to calculate. It's very good in Mathematica.
Yeah, obviously.
Okay. So the Laplace transform essentially transform from a real variable to a complex function. So it's like time domain to a frequency domain, but it's a real variable to a complex.
No, yes, time domain and frequency domain. But after transformation, there is also a figure domain.
So it's a complex frequency domain.
Moment.
Or plane. It's called a complex frequency domain. It's not
you're surely representing these exponential diagrams where of the transmitters, right, which you're referring to, where you can see the wave characteristics of your transmitter in this representation.
So you have both real value of the frequency and the imaginary value of the frequency. That's the reason. I mean, it converts from a real value to the real frequency as well as imaginary frequency. It's a complex frequency. Complex value of the frequency.
Yeah, but anyway, it's just math. It's a representation. It is not physics. It is just
mathematics,
a tool.
Yes.
What I try to say is all tools, including iSpace, are not in any form directly managed to say this is physics. I'm tempted to say this is physics in iSpace because iSpace, with its reductionist approach, is so simple now in multiplying really minimalistic integer values with geometry and getting constants of nature that I say it cannot be accidental. But what probability, in the best sense of the word, to be calculated for such a value? How likely it in 1 to infinity it is that this is accidental or not? I wasn't able to come up with yet. So I think that was one of the questions Stephen Wolfram asked me when I was visiting him at the time at the NKS 2012. I said, how probable is that it is accidental? He said, I have no idea. You're the mathematician. And we never got deeper into that field. But that was surely a very, very good question, because if you are claiming that iSpace is physics, with what probability would it be physics? With what probability would your theory guard be physics? Is that a calculable entity? What would flow into such a parameterization for such a judgment? For sure, constants of nature, because without correct constants of nature, anything of the theory is likely not correct. But even you have constants of nature correct, they are subtle in a way. When you press down right side, it pops up on the left side because they are all multiplicative combined together most of the time, or even exponential or higher order. And then the errors go quickly out of the range you want. But I'm pretty sure a good mathematician in statistics who would work with our theories could give us hints on how we could find a more objective way on calculating how probable that it is not all accidental. But maybe
there are things like the Bayesian analysis. I think it's one of the ways probably you can figure out Bayesian. You heard about
but this is just, he would take all measurements and see if they are properly. I have a zero error theory. So zero error theory cannot be fixed Bayesian-wise, because it will, with every experiment, give you the same result. That this is the exact value, take it or leave it. Yeah. So iSpace is special because of this zero error bar thing, which most people don't even believe is possible. But this is the only way in iSpace. Either it's fully correct or it's completely accidental. And this is with what probability it is accidental or correct, and how to figure that out. I have no idea.
I think there is a weightage, like expectation value, things like that. Expectation value is average value, but you have to take variance. So
against what? If I only have one value, what is my variance? I have none. So when you measure all data values from 1998 to 2018, you sum them up and divide them by some statistical formulas, you can do variation. But if you have only one value, what is your statistics?
Yeah, that's hard. So you have to get some data. Like I am doing data modeling with.
I'm thinking more on something more deep. That is entropy. When you have to take one multiplication sign, then you do something, you do an operation. When you do an integer number and that integer number is 1, it has a very, very low entropy. I mean, it's just a single bit, essentially 0 or 1. But when you do a number like 6961, you need to code the number 6961 and say, this is the 34th prime number, or I don't even know what it is. So some prime number in a range. Then you encode the prime number, digit 6961 to a lower number, its order of primes, for example. But you cannot be reducing it more. This is the best coding you can find. So when you take the bits for this and the bits for that and the multiplication, and you need for all operations you do, I only do multiply or divide, then you have the inverse bit. So you would get a set of bits which give you a constant of nature in I space, and that number of bits is an entropy. Now the problem is when you have a differential equation, what is actually the differential equation's entropy? And how to calculate the number of bits of the differential equation. Has it to do with the precision it calculates? No, not really, because a differential equation can give an exact result, even depending on the geometry you use. This is really, really hard to judge, and for me, it's just an idea into the blue to say that maybe we find a good mathematician which is valid or willingly help us here in this range to sort that out. Because this question, is it numerology or not, is it physics or not, will always come up with new ideas like that. Even Manuel has a hard time with his over the speed of light models and stuff like that. People don't accept just new ideas unless they hit hard problems in the old model. And today, this morning, I wrote a comment on a new question in ResearchGate, which was posted I think only recently, a couple of days before, by John Macken, and I gave a clear feedback on Hubble constant and its value and why. Simple things like they discussed if the Hubble constant times the world age is in frequency calculation something of the speed of light, and said, yeah, what else do you think? It's not about 2.9 to the power of 8. It is exactly 299792458, and when you don't believe it, here is the link.
Yeah, but your I-space theory, there is one value missing, the second Hubble parameter.
I don't even know physically what that is. I have to really, really sit together with you to understand how you calculate that, to see what that would be, or what would it do? So what is the physical significance of the second Hubble parameter? Because one is definitely the world age. I'm absolutely sure on that. And the world age shouldn't be told. I think people always say the age. The age is wrong because you don't know what the age is. When you define world age as the visible universe, then I think you're correct. The visible universe is by the definition of constancy of the speed of light. If you like theory of relativity or not, there's nothing to do with that. So we need to start with something. So when speed of light is constant in all reference frames, then this multiplication gives the visible universe world age. You will not see light of a star older than Hubble constant multiplied by this frequency. Hubble constant is the frequency multiplied by this world age. And that should always equate to exactly speed of light, not.
That's the main problem. That's the main problem of all people who want to calculate something without correct world model. You cannot say the one has his world model and got one result. Another people has another world model and got another result. That's
absolutely.
I cannot say what's behind.
I have this I space, which means I do only constants of nature, and the combination of constants of nature, which was not even my own invention, gives such a good value that is really, really unlikely due to the geometry which I found. It's not the numerical value which I'm after. I don't care. The geometry of the equation in this I space paper is the most interesting one, because It shows exactly how the speed of light and the geometry of golden ratio squared goes into that value. Now, when you tell me what the hell is golden ratio squared in your equation, Christian, and then I say I have no idea. So this is the interesting thing to find out. Why is golden ratio squared into the equation of the Hubble constant? I wish I would know, but I don't.
But I cannot say you what is behind the word radius. It's cannot answer this question.
Yeah, from the pure light model, where you have a light cone, and the light
you
cone
need a model. Yes,
the light cone says you cannot increase the speed of light, and if you cannot do that, Emmanouil might be thinking on other ideas, and they might or might not be true in the end. But the pure heuristical world view we have today is that our universe is about 13.7 something years old, and the precise value is not the critical point in this discussion. The important point is whatever model you have, you get a number, and that number dictates you cannot look far. You get no light from there on, and that's it, because of the concept.
I calculated two values of the Hubble parameter. One is nearly the value you calculated also, but I cannot say which is the correct one.
Yeah, but if I'm right, your model is smaller, which means you have a curve going before the light cone ends down for a geometrical reason of your model, and that is fully valid. Would you have a model which go down after that? You either prove that when your model would be correct, that something is a bridge between this faster than light and smaller than light thing, where Emmanouil comes in and says, see, I told you there is a way to bypass that light cone, because then your theory would essentially bypass the light cone. But as far as I have seen your paper and understood correct, you do not do that. So you stay inside the light cone with the smaller value. The whole question is the newest paper. There's a new measurement, by the way. I can also show you that. It came also out last week. There's a new measurement of the Hubble constant from a Chinese team. And they did very, very precise measurements of that thing with a lot of new stuff for the best of the things which they have. And they completely nailed the value in the range where the eye space is. So in the 72, not the 68 one.
Yes,
and the 68 one, the only one staying in their paper is the CMB value. So you have to understand what your paper calculates for the CMB value. So what is the CMB value physically? With respect to the Hubble constant from constants of nature purely, when the new Hubble constant.
Yes.
So this is the right question.
What
is your model?
That's why I calculated both values, and I cannot say which is the correct one.
Both are correct.
So maybe
but you need to give them a physical stamp to say this means X and this means Y. So when one of your values is compatible with the eye space one, then you know for sure that one of these values is the constant of nature based ones, quantum mechanics. And when the other is cosmology, then very good. I'm not talking about cosmology except defining a precise G, and it is more than others too. But that means the cosmic micro background picture, when you know that picture which they scanned with the Planck satellite, it gives these nice ellipses with the temperature zones which are warmer or colder, and they should be more or less isotropic, but they are not. There are zones which are hollow, which are more warm, and others which are more cold, and they are not fully isotropic as they should be. They were very surprised. And whatever that means physically, their calculations seem so good peer-reviewed that they are not wrong from a pure arithmetic, whatever. They are not idiots when they do that. I trusted that and met a lot of clever people, and they know what they calculate. So no one yet explained what the cosmic microwave background actually is. They tell you there was a Big Bang. We don't know. They tell you it is that the remaining frequency of the photons of that Big Bang, whatever. But if eye space theory has something to say, it could be quantized, and when we know better than nothing, quantization changes values and not often small ones. So it could be.
But I calculated
quantized eye space value of the calculations they done with the cosmic micro background calculation. They could even get a 72 value.
I have my own model, and I calculated it from the Big Bang. But at the beginning, there is the universe consists only of one Planck unit, and there is a little problem.
And the little problem is called inflation, Gerd. And when you start from
no inflation. But I can.
But the inflation calculate model is that what makes the CMB wrong, because there is a time needed for inflation, and while inflation happening, time isn't even valid physically because it's not defined while inflation is superluminal.
I can calculate the background cosmic the CMBR I can calculate back until the Big Bang.
Yeah, very small time, but not zero. I bet my ass not zero.
Not zero. Yes, when my Q factor was 1/2, yes, 0.5. Then the cosmologic background radiation has been coupled into the and then the cosmologic redshift and so on came. You can all read in my. I can also say.
Gerd, is it the first epoch? They call it first epoch, right? Epoch.
Yeah.
Is it the first epoch?
My model weicht ab, diverges from the standard understanding, because most people say the cosmologic background radiation, the beginning was 3,000 years, or I don't know the exact value.
The book, so we talk about the Weinberg book, right? Where it's
but my model is totally different because the photons at the beginning behaved like neutrinos and vice versa, and that's why the photons could not be affected by any particles or ions, and we did not have to wait for the recombination because the background radiation could be lead back to the point of the Q factor of 1/2. It's
is it gamma or X-ray? Is it gamma ray or X-ray?
Not gamma ray. What?
Only X. What is it? Is it X-ray? Is it X-ray? Initial.
The cosmologic background radiation, the 2.7 degrees.
So you are Hubble constant, the two Hubble constants. One may be with CMBR, the cosmic microwave. The other may be gravitational waves. Did you consider that? The possibility of gravitational waves?
The difference between both values in my model is once
the black holes. The black holes. If they're black holes, were they initially? They will
no black holes. It's because all is calculated from the electron mass and electron radius, and the electron radius has especially curvature, and if I calculate it with a curved electron radius, I get the one value, and with a not curved electron radius, I got the other.
No, that is really an interesting information to me, because that says when you change in one way or another the geometry, of the electron, you get one value of your CMB, which is compatible to I-space, and with the other geometry, you get the CMB-based one. Do you know by any chance, without looking it up, how precise your value in the calculation when we have put the I-space values in? You're sitting on this 68 cosmological. How precise are you on that?
I'm
Master, remember, you are very precise on the 68, I think.
So it could be gravitonic. Like Emmanouil is saying, gravitonic, you know, it could be gravitonic, and then it became photonic. So it could be the difference.
Rajan, wait a moment. This is just an important thought.
I'm looking for
conclude.
And it's the end.
Because we haven't not talked about the details of the two values yet and about the implications, but you summarized that now in a wonderful sentence, that you have changed the electron geometry, and I-space is doing nothing like changing the electron geometry from a sphere to a either fractalized, but in any case, non-regular structure, which is more likely a six-fold or six-dimensional than anything else.
Oh, you mean the electron structure in terms of a cloud versus a spherical?
So the normal electron is a point particle in quantum mechanics, and point particles are just brain shit. They are not existing. They are for mathematical calculations of renormalization, and people who want to do renormalization need to accept point particles. I don't, and many other people by now also don't anymore. So you have a geometrical model of an electron, and the geometrical electron model means you have a size, and the size is by no means the classical electron radius, nor is it the Bohr radius. You need to know how big your particle is geometrically, and I-space theory knows it to the pixel. So the I-space theory with the number 1111130 tells you this is the electron mass, and when you transfer the mass
geometry,
you can calculate the size into the octometer if you want.
But what is the geometry? Is it a Horn torus or like?
Yeah, it's a torus. Yeah, geometry is a torus because it's six-dimensional. It's naturally a torus. Absolutely.
So, Calabi-Yau manifold type.
Yes.
Calabi-Yau.
Yeah. But the size of the Calabi-Yau manifold is interestingly 0, because a Calabi-Yau manifold has no outside, just inside, and this makes it a point particle. This is why it is actually why quantum mechanics is right on that.
I found
if you only have inside, then you have a 0 size. Yeah.
No, I found
the effect of the mass with no geometry in the outside.
The expression for both different values of. I could present them. Moment.
I have not told you that I actually have not so much time today to discuss that online. We should really make an appointment.
I can tell you it's the metric universe at page 269.
The problem is if I would understand that or not. I'm absolutely not sure I'm able to mathematically understand what you have done there. This is probably needed step-by-step guidance by the person who have written it, to put it this way.
Yeah, if you want to put it,
the thing with the electron radius is at page 210.
Yeah, but I think we just learned something very important, namely a possible bridge where the models could be compatible, and this is what I'm at least seeking. I want to understand how I-space is compatible with any model for that matter, but of course I can't do it alone.
So one of the things I'm doing with Emery Taylor is discontinuum physics. So we find that it's a discontinuum length. So actually the basis should be Planck time, not Planck length. So the Planck time is the basis, and your time that you are coming up may be the correct one. And
the Planck time is a time deduced from G. As G is exact, you get an exact Planck time per definition, because Planck time is defined as Haber C over C to the power of 5 over G in the root of something like that. And this is easy to calculate, but it is likely not the physical minimum time. The Planck time is not the physical minimum time.
No, what I mean is that
time. when you have Planck units, you set certain values to 1 in non-ice-based calculations. When you do SI calculations of the Planck things, you get the values in the books, obviously. Yeah.
Yeah. So one of the things I come up with
the ice-based values show that 1/6961 is only a time in ice-based IQ unit system, which means in SI unit system I have to do tricky multiplications with the human artifact factor. The human artifact factor is 47 times 14,665,487 divided by 10 to the power of 24. So this is this ice-based base time. I call it ITBHA, ice-based base time human artifact factor. And when you multiply that with 1/6961, you get the ice-based base time, which multiplied with golden ratio gives the electron charge.
And what is the smallest time according to ice-based?
So you cannot easily say in ice-based IQ units, is it a big time or a small time? Look at the scaling relation. When you have the ice-based base time, this is a microscopically small time, 10 to the power of -19 seconds, 19, yeah? So the best frequency counters we have in the world, the best clocks are 10 to the power of -18, 10 to the power of -16 around, but they have a narrow range. So you can precisely measure 10 to the power of -15, and that's it about.
Yeah,
so we need 5 more decades to the 19.
So like a laser, with a laser, pulsed laser, you get...
Yeah, but whatever you have as an atomic clock, build a better atomic clock and you get a better time. But 1/6961 is a small number and is not so far away from golden ratio. You know what I mean? When golden ratio is the charge also in SI system, and 1/6961 is the time, and you multiply that, you get ampere second, you get ice-based ampere ice-based second. But 6961 is not far away from golden ratio. It's about, say, 1,000 times smaller, whatever. Yeah, about decade-wise, 10 to the power of 3, and not 10 to the power of 19. So you have to get all human artifacts out of all your equations, and that is only possible when you recalculate all your equations, not in SI system, but in ice-based SI system. And how to do that? You have to convert kilogram by volt ampere second to the power of 3 over square meter. You have to calculate Newtonian force, volt ampere second per meter. You have to go coulomb in ampere second, and so on. You transfer just purely stupid mechanically units. And then you put ice-based values in all your units, and everywhere where you have a charge, you please use golden ratio, and everywhere you have a second, you use please ice-based base time. And when you then take in Mathematica and the ice-based IQ unit system, you can automatically convert that, because you can always see how many of the prime numbers 47 times 14,668,487 you have in your calculation. Is it to the power of 1, to the power of 2, to the power of 8? It depends. Is it in the divisor or in the dominator? It can be both, depending on where your equation started. And then you know what is the human part in your calculation. And then you throw that out. And what stays is ice-based IQ unit system. This is not proven yet. I have not written a paper on that. But this is what I 100% assure you is always correct when I try manually. I have not found a single counter example so far. It always works. And the last time where I didn't believe it works was G, because I said, how much ice-based base time is actually in G, I didn't know. And since I know that the Planck force times alpha G is the quantum of gravitation squared, I found that in G, alpha, ice-based base time artifact factors to the power of 8. And I guarantee you that is for sure correct, which means I have now a G in ice-based IQ unit system, which is the proper unit. Otherwise, I wouldn't know that, because I have only 4 measurement tickets. I have nothing to compare. How could I know? But by this trick, by knowing what time to divide out, something stays. And that is for sure the proper rest, because it worked in Coulomb, it worked in Newton, it worked in all other equations I had in the Planck constant, so it's also correct for G. This is just an assumption, but this is a very, very, very valid assumption. And then we apply that to other models. Then we can quickly see what is the force ratio in ice-based IQ unit system numerically. And the force ratio is numerically, and this is the cool thing. In ice-based IQ unit system, I can show you that the gravitational force is equal to the electrostatic force.
Oh, really?
And in G, this is in SI system, this is not at all the case. In SI system, you think it is 10 to the power of 42 smaller. Yeah. But this is an artifact. It comes from the human definition of time. It comes from the SI system itself.
So gravity electrostatic, you are saying.
Gravity is electromagnetic force. That is what I'm saying. And a lot of people, for other reasons, are also saying that. There is no gravity. This is all electromagnetic. And in the right dimensionality, it works out. And in the right unit system, you can.
So the graviton and the photon are the same thing, right? I mean, except.
No, the graviton, what is a graviton? I have calculated the mass of a graviton, and the graviton is mathematically an extremely easy thing. It has the number 11 in it. So think that the electron has 1111110, so 1111111 times 10 plus 3. So it's 1111130 actually, but the 3 is a fence that has to do with I-space geometry. I-space geometry needs a fence, plus 1 left, plus 1 right, because we have no infinitely thin borders. If something is in a box, the border has weight itself. And there's where it comes from. And as this gives correct electron mass, it cannot be accidental. And I need to do the similar thing for the graviton, but there it didn't work. With the 11 number, it did work alone. So the graviton is some very, very special thing. It is not a normal particle in the sense of an electron. It is uncharged. It's super simple geometrically. It is small.
In my model, it is charged, but the charge is different from that of an electron. And
I hope so, because otherwise it would be wrong. You can. So you see that there is no golden ratio in the geometry of the graviton which I calculate from a pure mass, and I have not seen a charge so far.
But in my model, it's not named graviton, but metric line element or MLE.
So an integer thing in a sense, countable.
So what happens? Your I-space time and the time square could be, one of them is speed. The other one could be acceleration. If your time square normally is inverse of that inverse of time square is an acceleration.
No. Why the time is 1/6961 is purely mathematical. I cannot tell you. The number 6961 is a frequency. Yeah. 1/6961 is a time.
But you have a square also. In one of the things, 6961 square.
Yeah, when your equation squares, then I square 6961. So when you see the 6961 to the power of 18, in some equations I do, then you know you have the time in power of 18 in your equation. And that is not very unlikely that goes fast. I mean, think you do 6-dimensional stuff, then you have already to the power of 6, and then you multiply c to the power of 4. Then you have 4 times 6 is to the power of 24 is the result of the exponent multiplication. And that's it. It just depends on how many exponentiation you aggregate. It's all multiplicative. Don't forget that. So it can be easily factored out again if you want that. So I can tell you what is in your equation from the result equation. That is the cool feature of I-space. I don't need to understand your physics. You give me your equation, I type the equation in Mathematica, press return, and look in I-space as I unit system, what value do I get? But this is irrelevant. And then I look what geometry do I get? That is not irrelevant. And from the factorization of the integer numbers we get, and it can be very, very long. In the case of G, they are 223 digits long, and that doesn't matter. The factorization will give reasonable physical values out of that. And the hard work is to find plausible physical equations for your factors. So that is not always obvious in the beginning. At G, it took me a year to find from the original equation, which I derived by coincidence with a Campari soda sitting in Italy in vacation in the Adria beach in Jesolo. And it took me a year to find out. But what I found out is that the equation, the first one I had was the complete correct one. It was just unclever multiplied in a way which is not very physical, but it's not wrong either. It's just not clever to write that. Because, for example, when you have physics, you say G is a force times M1, M2 multiplied over radius squared. And you can put it on the left side if you want. So a force is G times M1, M2 over radius squared. And when you put that on the left side, you get G equals radius squared over a mass squared, obviously. And that is the most simple deviation I found for the quantum of the gravitational constant, because it turned out that the radius you needed to square is exactly the root of Bohr radius times classical electron radius, so a quantum mechanical thing, or it is Bohr radius times alpha, as you choose, is also quantum mechanical, even more. And the mass you needed is just the electron mass squared, and it cannot be more simple, right? So the electron mass squared over the Bohr radius times alpha times the quantum of gravitational force, which is nothing less than alpha G squared times Planck force, or in I space 3 over c to the power of 4, multiplied with a decadic factor of 1 over 10 to the power of 3, which we don't know physically yet what it is. But it doesn't go away, because the mantissa of C has 8 digits in 299792458, and when you do that to the power of 4, you get a really long mantissa, not 42 bits long, but around 27, I think, 28 or something, and the rest is just zeros. But even if you don't put exactly 10 to the power of 3 in there, but 10,0015 to the power of 3, it doesn't change anything on the first 27 mantissa digits. So it's very valid to say C over 3 divided by the speed of light numerically to the power of 4 is essentially that what makes the force of a quantum of gravitation, the force of a quantum of gravitation. And once you have that value, you can also calculate the mass of a quantum of gravitation, and the time it takes when you divide by C again. So this is all just standard physics. You can, once you have one value right of these 3, they are all triangles. The rest is just really simple multiplicative 10 class algebra. Nothing special.
Yeah.
No really complex things here.
In the paper in a Canadian journal, I have put gravity is nothing but a sphere of influence, so it is so I have proved that, and there will be strong gravity and weak gravity, these type of things. And the other aspect is a superluminar thing. The superluminar, you cannot find the geometry. So what happens is superluminar, then the vacuum is where quasi particles and partons, things like that happen. So that's where it keeps the speed of light constant, the vacuum. And then there will be subluminar to get actual particle. So the particle can have only maximum the speed of light. It cannot exceed that.
Yeah, and the I-space theory tells you exactly why that is. Also geometrically, in the I-space theory, you have an ether. And that ether is rotating cells with speed of light. And every mass of every charged particle has a radius. And that radius, when it's maximum, it reaches the speed of light, which it cannot reach because the I-space pixel for the border has already the speed of light of the ether medium. So you can reach the speed of light minus 1 pixel as the maximum speed in I-space. And that makes absolutely sense. Now, when you have an uncharged particle, one might say, okay, it could traverse faster than the speed of light. And I agree to Emmanuel's ideas here, but these are
the graviton.
These are longitudinal waves. They are not that what normal pressure waves. I have an interesting video which I have not sent you. I'm not sure if I sent it Emmanuel in a one-to-one translation, but I sent it someone. I have to think. That is when they have 2 sound clocks instead of 2 light clocks. You know the Einstein experiment with the 2 light clocks in the elevator and between the 2 mirrors, which tick in 1 second by left and right, sending a photon between 2 mirrors. And when the elevator goes up, then light has to travel a longer distance by the 45-degree angle.
But we falsified that with Emery-Taylor because it is 2 different reference systems. So you are comparing 2 different reference systems. And there is a paper by Emery-Taylor and me, and also by himself about falsification of that light experiment.
Yeah, but it's just a model for the moment. In the thought model, Einstein is right. Yeah, so the thought model can show why time can vary with the movement at all, because when you have a light clock, time will vary with the movement because the light takes longer to reach the tuck. When light makes tick tock, and the tick is the left mirror and tuck is the right mirror, and you move the right mirror up by being in an elevator, and you started with the light emission at point 0, then when the elevator goes 1 meter per second up and it's a box of 1 square meter, then it will need a 45-degree angle, and you will have the root of 2 longer way for the photon to reach the left mirror again. So before the second tick, it will take exactly root of 2 longer. And this is just special relativity in a very simple way explained. Yeah,
it's just the path of the optical path.
But the tricky thing is this paper, what I'm telling you, is actually the paper by the YouTube video. And I'm not sure if I received it by Emmanouil, or I think I received it by Emmanouil. Then you should also have it. That created 2 sound clocks with acoustical sound. And the acoustical sound clock works like with light clock, that it makes a sound click and has a microphone which says, when it receives it, I send the sound back up. So it makes tick-tock like the light clock, just with the sound clock. And the cool thing is, when you then have a drone and take the second sound clock sitting next to the static one, the stationary one, and fly it around the Earth and land, then the flown around clock shows the exact same relativistic deviations. And why is that? Because sound is transmitted in a medium.
Yes.
And because it's transmitted in a medium, the speed of sound in this medium, and as it is probably right, the speed of light in the medium and not in nothing. Yeah? And then you don't need this relativistic brain shot, which you need to do with Hilbert geometry and all that. It's just really much simpler. Assume a medium, and you get a full relativistic theory by 2 sound clocks. I mean, Jesus Christ, it cannot be more simple, really. It's super easy to understand.
It's a pressure wave. I mean, sound is a pressure wave. So
yeah, but has nothing to do with that. It is a pressure wave in a medium with constant sound. The difference between a sound clock and a light clock is the light clock always emits light with the speed of light, no matter what the speed of the moving clock. But in sound clock, that is not at all true. The sound clock works like a clock, and always the speed of sound is the same, regardless how fast the movement of the sound clock in air. The sound clock will accelerate, then fly around the Earth, and decelerate and land. Yeah,
but light is instantaneous. I mean, there is no. I mean, it becomes immediately the speed of light. I mean, there is no acceleration.
Yeah, but for the sound is also no acceleration. This has nothing to do with the acceleration of the theoretically emitted light particle. It has to do with the speed of sound is a constant in air. And in a medium, it is also a constant for light. Just Einstein and others let us know that there is no medium. And I beg to pardon, this is wrong. If you assume a medium, instantly you can have the analogy of the sound clock to the light clock, and you get the full relativistic effect without theory of relativity. That's simple, okay? That's simple. All the complex calculations can be explained, and quantitative, not just qualitative, with the model that you have an ether and the light is emitted with the speed of light in the medium and not relative to the emitter. All the problems you get in the deviations of relativity, especially special relativity with the twin experiment and all that, what you can do theoretically are counter explanations to that. They get very, very complex why that is still correct, and they have to accelerate and decelerate, and you have no such need. Would you just assume an ether and make a light clock where you assume that light has a constant speed in that ether regardless how fast you move?
Yeah, the constant speed comes because of the what you call the equilibrium between superluminal and luminal.
Because of the rotating cells. The light is following the rotating cell like rotating glass doors in a Kaufhaus. You know, when you go in a shopping center, you have these rotating glass doors, and you cannot enter the shopping center faster than the glass doors rotate. That is your speed of light when entering the shopping center. So what medium do we travel in the shopping center? We are person particles and enter the shopping center in a medium called air. Otherwise, we can't breathe. Now, what is the maximum travel speed in air? Is not the speed of light, because we burn fast. But when we are a sound wave, then in air, travel speed is the speed of the sound, and that is constant with 330 meters per second or something. And look at that video. The YouTube video in 10 minutes tells you why that is physically correct.
But the maximum speed is not sound speed, but the first cosmical speed.
No, for sound in air, the maximum speed is the sound.
So for sound, but for other.
Don't forget, this is a model. But the model and the mathematics of the model for sound is one-on-one transferable to light and gives completely correct relativistic results without imposing anything of special or common relativity. It just works.
I think sound and light are interchangeable because of the coupling constant. It depends on the coupling constant. So you can change sound to light and light to sound depending on the coupling constant.
Possibly, but the sound wave is a pressure wave, as you see. Light waves are not pressure waves.
At least they
could be pressure waves in a medium, but they are surely not pressure waves when you calculate them with Maxwell equations.
Coming to a differential equation, one of the things that we found that discontinuum length may be a constant. So if you use a differential, then it goes to 0. That becomes that. But what happens is the higher differential, you have singularity, which is not correct. I mean, that's the problem of the Maxwell equation, or even Einstein, that the singularity is not correct, first of all. So that's
I never liked the Maxwell equations because they don't explain at an instant how a magnetic field becomes an electric field, because you have a 0 in between. You know? When the curve of the, say you start with the maximum and the magnetic field goes down until it is 0. So can you please explain me how a 0 magnetic field will induce to start the electric field at that point? Because when it is 0, it should stop there, and that's it. But you have impulse and energy conservation, and for that reason it continues. But that already tells how silly the equation is, because from a purely equational point, the thing should vanish. It's 0. From 0 you get nothing. Ever. Nowhere. You multiply with 0, it's 0. So the force is gone. Poof, evaporated. This is just mathematical nonsense. So at the 0 point, the whole equation is not even defined.
I also believe that there is no 0 really, because it becomes constant, and when you do differential, it goes to 0. But differential, the actual thing is not 0. The actual value is not 0. So even if the point, you have a value I, which is not 0. So
I mean, when you press a balloon up and you have a second balloon in a vent, and you open the vent and the top balloon presses all its molecules to the bottom balloon, and you close the vent, then you obviously never had 0 in the game. You opened a vent where you have a passage which is small, like a millimeter diameter, and all the atoms or molecules of the CO2 or whatever was in the balloon went from one balloon to the other balloon. But at no time a discontinuation was happening there. Molecule by molecule, integer counting went from one balloon, transferred to the other balloon. So the other balloon is full now, went closed, and then you reverse the balloon like a Zen clock, and it goes back.
So the energy
but this is not what differential equations do. Differential is just in your brain. This is just mathematics, is not physics.
That's because you are seeing only one part of it. You are not seeing the whole part. That's the problem. So if you see the whole part,
a curve cannot be infinitely thin. Infinitely thin things lead to infinity and to 0, and that is physically nonsense. Nothing in physics ever, whatever it is, will be infinite or 0. Nothing.
No, that's an artifact.
It is an artifact of the mathematics, exactly. But you need to be aware of that. And people make clever differential equations, solve the differential equation, make crossing points, and say we have this and this force. But the force in this curve, where the curve's cut, is an approximation, is not exact. They think it's exact because they solved the differential equation. But what I'm saying is, when they counted atoms, it would be exact. The best example I can give is when you have ampere. What is an ampere? It's a charge flowing, right?
Yeah.
So it will give a magnetic field when a charge flows, because a moving charge makes a magnetic field.
Flux. Yeah, it's a flux. Yeah.
So, and when you look on the area, so the strength of the magnetic field is defined in Tesla, right? But Tesla is just a name of the guy who has been honored for whatever he has done in his life. It has nothing to do with physics. So what you physically get is ampere multiplied with meter squared. So you have an ampere multiplied with an area. And this area, let's say, is 1 square meters in whatever dimension. Can be I-space meters, then you're counting pixels in both directions. Whatever you have is a measurement of an area. And when one single charge is flowing through that area, then you have a line going through that area from bottom to top in 3 dimensions. And that is discrete. You can count the number of field lines going through that area. It's 1 field line, 2 field lines, 3 field lines. And with every electron in your equation, it is an integer multiplied with n. You get more field lines in your area. And that is what is Tesla. That is your field strength. So in other words, there is no integration of a field strength. You're counting discrete electrons. And that gives Tesla. And that is what you have to understand when you do physics. Everything always has a discrete model behind. When you electric charge is really a nasty thing, because the electric charge involves in so many equations naturally that I think everything is based on electrons and positrons. There are no other particles. Everything else in the right geometry gives all other masses we have, all other geometry we have, everything in the universe, including gravitation, is solely built by electrons and positrons and nothing else. Now, in I-space, the electrons and positrons are aggregates. They are not a number, or say this is an atomic golden ratio thingy. So the value of the charge is golden ratio, but the mass is complex. And when you have a complex mass, this is really good because you can divide the complex mass. You can divide the complex mass and split a neutrino off. But then you have an incomplete electron. What do? You need a sea of some things, of neutrinos, where you recollect this lack of emitted energy back in a dynamic way. It is very dynamic, because when I steal the electron energy, this is not allowed. Stealing energy is not allowed. So I need to get it back, or the electron is incomplete and would disaggregate and emit even more energy in form of light waves. And
storage,
this is exactly what happens when you hit electron and positron together. You get light waves in the Röntgen area energy, and the electron and positron is gone after that. But where actually has the charge gotten? The charge is not in the light at first sight, because light is not charged at first sight. But there are experiments also recent who show that light is bending to magnetic fields. I repeat, light is bending to magnetic fields. Not a lot, but a little. Very, very few. There's a recent experiment which says something is charged inside. So it could very well be that a photon, the electron and the positron charge is not gone, but in the combined photon flying away is the electron and the positron in a combined neutral way hidden inside the photon, and hence everything is just charge, including light.
Yeah, I think we proved with Emery Taylor, one of the papers, that there is a charging cycle and also there is a propagation. And it's very clear. We are like 7 papers now. And if you have a chance, I calculate exactly this thing. So the charging cycle, and then you have a propagation cycle. So charging cycle is when, so that's how it keeps moving. So it means
what is your model telling about the emission speed? I mean, light is emitted at the speed of light, right?
Yeah,
but light has also an impulse. It has no mass, but it has an impulse.
Yeah.
And most people don't understand what impulse is, but geometrically is actually easy to understand, because
force times
you
time.
Have mass,
force times time.
When you have mass, then you multiply with c squared, and when you have impulse, you multiply only with c. And this is that simple, actually.
Yeah,
so nobody really knows. So everybody knows what energy times c squared is. That is a mass. But when you multiply energy just with c, you have an impulse.
Yeah.
And nobody really knows in books what that is. And from an I-space, I can see what that is, because I see the geometrical solution by canceling out the rest.
Yeah.
And what I can see is something accelerates from zero, from a Zitterbewegung style rest position to the speed of light, but nothing can be accelerated in zero time from zero to the speed of light, because impulse means energy, and energy is a form of mass. So we would accelerate mass in zero time from zero to speed of light. Is just somehow it really looks wrong, right?
Yeah.
Nothing. You would need an acceleration time. But what is a model for showing a correct acceleration time of light within the atom, and when it leaves the atom area, it suddenly has the full speed of light? And look, what the I-space model is telling you here is when everything rotates already with the speed of light, then it is super simple to assume that in this carousel, anything which leaves the carousel will immediately have the speed of light without acceleration, because at the border of a carousel, you have the speed of light as a border circular frequency.
Yeah, you have vortex action.
It is completely natural to assume light has always speed of light, because anything, whatever it is emitted with the speed of light, unless it has mass. Because when it has mass, it cannot rotate on the border pixel, it rotates inside. It has very much less rotational energy, or a minimum less than the speed of light, but it has never the speed of light. The last pixel is missing in discretized I-space worlds.
Yeah,
and that is completely natural in I-space, because when you have a disk, and the disk is made out of pixels, and you're sitting on the center pixel, then the center pixel also rotates with the speed of light, but the distance it curves is microscopically small, while the distance it curves at the end of the carousel is comparatively big. I mean, go to a children's carousel on a playground, sit on these rotational things, and keep inside, and beg someone to rotate you, and you keep happily inside, and then go to the outside of the carousel, so to the 1 meter or half a meter, whatever the carousel size is, and let them rotate you a second time, and then stand up. And I bet if you're lucky, you fell not out of the carousel. Because, So this is the difference when you are very much on the outside or on the inside of a carousel.
That's conservation of momentum.
Yes, exactly. And it is a mechanical thing. It's a Newtonian thing in such a model, but you need an ether once again to easily explain why that is. Without an ether, all this stuff is gaga from Maxwell equation, which is mathematically correct, physically proper, but just in your brain. It has nothing to do with physics. It is not a valid model, in my opinion. It's just proper mass to calculate effect of electromagnetic field, in the sense of electric field and magnetic field separately, with a very complex calculation. And what Stefan Kühn has shown, there is a solution which is multiplicative,
which
is non-differential, and that means it is in principle possible to do it in a simple math without differential equation. And that means, in principle, any valid Newtonian model might be more near the truth of what the universe is really doing than we wish. Probably Newton was more right than we believe.
So is it classical then? Kuhn's work is classical, essentially classical?
Yeah, but the elements of what Kuhn's equation tell here are also classical. Just the multiplication effects, which he has in his solution, gives the proper answers. He has complete actio is reactio. So he has he makes the Maxwell equations a Newtonian thing in the end. That is why I find this paper is so cool.
I think
it shows how simple the thinking is behind all that.
Yeah, the modified Newtonian dynamics, they answer all the questions of quantum relativity, everything.
Yeah, Mond may also be interesting, but that goes to a different. They do plus signs there. They add things in this model.
Yeah, no, I don't use that.
He didn't change the things. He just changed the explanation.
Yeah, I have used that one in transformed and showed that the whole universe is black hole. In one of the papers. I mean, not black hole, black box. Black hole is only a specific form of black box. Black box is more general, and black hole is just one example of a black box. Black hole.
Yeah, some people don't even think that black holes exist, but I wouldn't go so far. I think the equations of Einstein.
I don't need.
are correct by the mathematical numerical things. When you go like this and see that if a certain mass is exceeded, it collapses and the mass cannot escape. But I give you a simple model thinking as a homework. I need to leave soon now. I have just a couple of 4 minutes left. Sorry.
Okay.
But I want to give you this homework, not for next session, but for really permanently thinking on that. Think Einstein has not predicted black holes, but Chandrasekhar gave him the Chandrasekhar limit, and after that we have black holes. Okay.
Short side. Yeah, short side.
So forget for a moment that other people in wheelchairs have told us that they might be evaporating to white holes and all that stuff with quantum particle in and out and all that. I don't buy it. Okay. I don't buy it for that reason. Stay for the simple things and say, let's assume for a moment we have black holes. So all the mass of the black hole in the theory of relativity condenses at the center of the black hole. It's a miniature point, whether it's an ice-based point or a really mathematical 0 point, doesn't matter for the argument here. You have in giant black holes, like in M1887, has a giant black hole there in our neighbor galaxy. And that giant black hole, I'm not sure how far it is away from the Chandrasekhar radius, but I think a couple of million kilometers. It's a really gigantic black hole. And
we have the galaxy. Milky Way, we have
the spaceship through that black hole. You notice nothing in the beginning, nothing. You have a long time to live until finally the gravitation effect kills you. But before that spaghettiing, or what they call it, happens, you have long passed the Chandrasekhar radius, and that's why you cannot escape the black hole anymore. Okay, so then I'm taught by all books I have read so far, nothing can escape a black hole. Would you agree?
No, Hawking's radiation. Hawking radiation.
Forget Hawking radiation. I said forget Hawking radiation. This is just brain shit at the moment.
Okay.
Then we forget Hawking radiation. Nothing can escape a black hole.
Yes, that's true.
Agree?
That's true. Yeah.
Okay, how can the fuck gravity then emit the black hole? Gravity has an effect, and the more which fell into that black hole billions of years ago, how would the gravity then come out of that black hole and treat other as an attractive force? And I bet my ass you have homework now. You have no answer for that. Nothing can escape a black hole. And at the same time, we have calculations easily showing that they must escape some force. Otherwise, the black hole wouldn't attract us, right?
Sorry, I want to end today and want to say goodbye.
Yeah, also I'm leaving in a minute. Thanks, Gerd, for joining.
Okay.
So this is really an important insight. So I believe in Emmanouil's superluminal model because that is the only way to escape gravity from the black holes, to make them work, actually.
Yeah. That's what we the first paper I have with Emmanouil is that
either the alternative is all of the mass of a black hole is frozen in the Chandrasekhar radius and it's a hollow ball where all the mass is on the outside, then gravity would still not really work, because from the outside the field force would be curled and it would not fully escape the near region of the black hole. It is much simpler to assume that mathematically the relativity theory is correct. The thing falls down to not 0 but a point of 1 logically, like in ice space, the smallest point you can have, and it aggregates naturally like there because there are no forces keeping it up mathematically. It is just a really aggregate on a single pixel, all pixels together at 1 point, but that point has still the mass of all points aggregated, whatever was the number n of the mass. And that mass has per pixel n a force. And I tell you what force that is. That is the force of gravitational quantum, which I calculated. The 10 to the 3.71 to the power of minus 46 Newton. Extremely tiny force. And every pixel falling into that black hole is quantized. So there is no continuous gravitational energy. It is quantized in numbers of gravitational force. This is what I predict here.
So I call it micro black hole. That's a term for the vortex field. You know, the black hole or micro black hole, from your thing also, is nothing but a vortex field, that is inside the black box, which is the big thing. It's just a vortex field during which charging occurs. That's all. So during that time, charging occurs, and then you have gradient where the light can go. That's a gradient field. Light can go. So it's just a term. Micro-black hole is a term that shows that your quantum of the thing during which the charging occurs. Because you also said the gravity is electromagnetic.
So we hopefully agree that gravity are necessarily to escape black hole's own attraction, or the black hole wouldn't be a black hole.
Yeah. So it's a magnetic thing that's going on. That's all it is. Magnetic, like magnetar things. So magnetic thing that's going on, and the electric thing, then gradient will propagate it. That's all it is. So, and
the energy of that propagation leads in a geometric way then to the force, which I can calculate in I-space theory, because in the end it needs to be a force, an attractive force. And attractive forces need to touch each other. So the quantum mechanics tells us that when two particles have virtual particle connections, then they throw balls to each other. This is what I learned in the theories when I studied that. And these balls, throwing forth and back, keep the players on the ball, on the field. Yeah, because when the players move away too much, they cannot catch the ball. So they want to catch the ball and stay on the play field. And that gives a virtual attractive force between the two players, because they just focus on the ball and don't watch for their position. And then they just play.
Yeah.
It's just an analogy, but this is what quantum mechanics tells why these forces keep the things together. If you believe that or not is another matter, but it's a good analogy, at least. But a quantized force, in my opinion, is the most simple thing in the universe, because when you start with the little and can calculate the big out of the little, then you did something right. And I calculate cosmologically right G, cosmological forces out of quantum forces, and the electrostatic force is an easy to calculate force. And I showed how the relation exactly of electrostatic force and gravitational force is, and the relation in I-space IQ units is 1, and that is beautiful, is the same. So there is a value for the gravitational force where you have G, electron mass 1, electron mass 2, so electron mass squared, divided by alpha G gives a value numerically, and when you have 1 over 4p epsilon 0, an electric charge, a second electric charge, so electric charge squared. You have another force between the electric charges, this time not between masses, but electric charges. And you do the classical electron radius multiplied by the Bohr radius and put a root over that, which is nothing else than the Bohr radius times alpha. So this is over to p. That is the radius value on the right, and then you get exactly the same number. That equation divided by the first equation of mass is 1. And that shows that electrical equation can be replaced with gravitational equations if you want that. So a mass-based equation can 100% replace the electrical equation. Just the dynamics cannot, because they have a curve where they cut. And outside of the curve is, of course, an equation you need to follow. But it is always mathematically possible to replace the electric values with the mass values, or vice versa in I-space. It's totally irrelevant to the same results. Yeah.
It becomes hyperbolic, right?
I don't know where they cut exactly. That I would have to look in the paper. I have it here. Let me have a look. I give you the exact value, then you get a more clear understanding. So what we're talking about is alpha G. This is 10 to the power of 42 divided by G times ME squared. And that is numerically in I-space IQ unit systems 6961 times P squared divided by 3. Really that simple, yeah? And the numerical value of it is exactly the same when you do it electrically. So G times ME squared over alpha G divided by 1 over 4p epsilon 0 times E squared over alpha works in SI system and in IQ unit system. Is unit system compatible. And when you solve it for a numerical value, you get the difference between SI and I-space IQ, and that, for the fun of it, is 2.71 times 10 to the power of 42. So this is the assumed 10 to the power of 42 weaker gravitation, which seems to be weaker than the electric force, but this is only adapted to the unit system. When you go to high-space IQ native units, calculate the force, it's the same.
Yeah, there is a weak gravity and strong gravity.
No, this had nothing to do with weak and strong gravity. It has just with the unit system. When you have a unit system which works with the real physical values, the quantized time and golden ratio charge, then the absolute mathematical difference between the charge numerical value and the time numerical value is small. Hence, you have no 10 to the power of something value. You have small ratios. But when you do the SI value, you have a numerical definition of the SI time. And the SI time was arbitrarily defined by some atomic jump with some frequency counter. And when you define it that way, you have a human artifact in there. And that human artifact multiplies in a way which I can easily show, squared with the speed of light to the speed of light in I-space IQ, multiplied with the I-space spacetime squared in IQ unit system divided by the I-space spacetime in SI unit system. And that gives 10 to the power of 42 about. And that is where all these misconceptions come from in physics. All the assumption that the gravity needs a unification on a total different end of the exponential curve is completely wrong. You just use a proper unit system and then you can see that. What the problem is, I have never worked with the weak force as such. I don't know how radiation, no, sorry, it's the wrong word. I don't know how radioactivity works in I-space. I have no idea. I will yet have to find out what happens when you emit an alpha particle, or in the simplest word, an electron, the simplest beta particle you can emit from an atom. And to understand that, I would need an equation for the mass of a proton first. And I have one, but I don't like it yet. It's not the right one. It gives a proper unit value, even with it fully the measurement value of Godata, but I don't like the geometry yet. I found it by analyzing what other people have done with the Thomas precession in their equations, and could calculate indeed the right numerical value of the geometric part of the proton mass from that. But while it is a beautiful equation, it's way too big. It's just not looking physical to me. But maybe also the idea of the Thomas precession is not the right way to pursue. But at least it gave a value. So that said, when you have a full atomic model, I have just an electron atomic model at the gravitation. But if you have a full atomic model, then you understand what happens inside the proton. And you understand why a neutron is neutral and what is the mass deficiency between a neutron and a proton and all that. And I have a very interesting model found 20 years ago by some Nikolai Kosinov. And the fun thing is, Nikolai Kosinov has recently put all his papers only half a year ago or so to ResearchGate, and ResearchGate did of course, recommend me his papers. And I had a chat with him already about that, because he found a fractal model of the proton. I think that is the way to go. Really golden ratio style fractal model of electrons and positrons in the right structural way, with the dynamics that all the shells get faster speed of the relative electrons on these subshells. And he's able to calculate the proton mass to a high degree, not perfect, but to a high degree. And why it is wrong in the end, it might be because he has no idea about I-space. At some point where he calculates the proton, he needs probably geometry which is not pi anymore, but pi 3 or pi 6 or pi 4 or whatever, at least non-Euclidean. And with the proper
it's
combination
not Taurus,
of...
right? Proton is not Taurus. It's not Taurus, like electron. It's not Taurus. It's probably...
I don't know. I wish I could tell you. I have no idea. It could be very complex. It could be very simple. I don't know.
Yeah. So one of the interesting thing I found out, there's a connection to vacuum decay. So there's a false vacuum and true vacuum. So I think the proton is in the false vacuum, electron is in the true vacuum. That's what I am coming up with. But I have to check that. And then your higher energy for the proton, higher potential energy, and lower potential energy for the electron and that will start the dynamics of the atom.
But are you saying that the proton is just a charged electron outside of space as we know it?
The false vacuum.
In a false vacuum, whatever that is, I don't know that. But but the charge is exactly the same. So when we know charge is golden ratio in I space, then charge is also golden ratio in the false vacuum. Otherwise, it would be wrong.
Yeah.
And we need to find the mass value for the proton from the electron then by having translation geometry, how the false vacuum needs to be calculated. I cannot help with that yet, but
if you find that, we can publish together. If you find something in I space, the false vacuum and true vacuum, we can publish a paper together on that. Because
sure, you're welcome. So I have to leave now. Really, I'm already over the time, 10 minutes.
Thank you.
Thank you so much for organizing that in the absence of all the others in vacation. And we reached the 2-hour limit anyway. And thank you so much. And probably see you next week when you have something or the weeks above. Yeah,
Christian. Hopefully, Christopher and others will join also next.
Was very interesting talking to you both here today.
Yeah, very productive. Very nice presentation. Thank you, Christian.
Thank you.
Have a nice week. Yeah, thank you.
Sure.